Introduction to Essential Physics Equations.
Physics shapes our understanding of the universe, from the tiniest particles to vast galaxies. Throughout history, certain equations have become cornerstones in explaining how the world works. Here, we explore the top 10 essential physics equations, breaking down what they mean and why they matter in everyday life and scientific discovery.
1. Newton's second law F equals ma.
Force equals mass times acceleration. This fundamental equation describes how objects move when acted upon by forces. Whether launching a rocket or kicking a soccer ball, it explains why heavier objects require more force to move and how acceleration changes in response to varying forces.
2. Universal gravitation F equals g of m₁m₂r squared.
Newton's law of universal gravitation reveals that every mass attracts every other mass. The force depends on the object's masses and the distance between them. This equation is vital for understanding planetary orbits, tides, and why apples fall from trees.
3. The Pythagorean Theorem a squared plus b squared equals c squared.
Appearing throughout physics, this ancient mathematical relationship describes right triangles. It helps calculate distances, vector components, and the motion of particles, forming a basis for understanding much more advanced physical concepts.
4. Conservation of energy E equals K plus U.
Total energy equals kinetic plus potential energy. This principle states that energy cannot be created or destroyed, only transformed. It helps explain processes from bouncing balls to roller coasters and is foundational in every branch of physics.
5. Einstein's mass-energy equivalence E equals mc squared.
This breakthrough equation shows that mass and energy are two sides of the same coin. Even a small amount of mass contains an immense amount of energy, unlocking nuclear power and explaining phenomena in stars and particle accelerators.
6. Ohm's law V equals IR.
Voltage equals current times resistance. Essential in electricity and electronics, Ohm's law governs how electric current flows through materials. It underpins everything from household wiring to advanced circuits in computers and phones.
7. Maxwell's equations, simplified.
Maxwell's equations describe how electric and magnetic fields interact, combining electricity, magnetism, and light. They form the basis for modern communications, including radio, microwaves, and the technology that powers wireless devices.
8. The Schrödinger Equation.
Central to quantum mechanics, this equation predicts the behavior of particles at the atomic and subatomic level. It enables the design of lasers, semiconductors, and explains the fundamental behavior of matter and energy at the smallest scales.
9. The ideal gas law, PV equals nRT.
Pressure times volume equals number of moles times the gas constant times temperature. This equation connects pressure, volume, and temperature of gases, explaining weather patterns, engines, and respiration.
10. The second law of thermodynamics, delta S is greater than or equal to 0.
This law introduces entropy, a measure of disorder. It states that in any energy transfer, the total entropy of a system increases or remains the same, explaining why some processes are irreversible and predicting the direction of heat flow and energy efficiency.
Conclusion: the power of physics equations.
These 10 essential equations form the backbone of modern science and technology. They help us build bridges, explore space, develop new materials, and understand how the world works at every level. Mastering their meanings unlocks the secrets of the universe and drives innovation.